let's find d squared y over dx squared. I wonder what all that means. Who knows? For the equation x squared plus 4y squared equals 4. Well, I wonder what that does mean. Let's start by just finding the derivative. So let's take this equation, we'll find the derivative, then we'll discuss what this means. And I do know what it means, otherwise we wouldn't be doing this video right now. So let's start with taking the derivative and then we'll discuss the notation. For y squared, we're going to take the derivative of this side and take the derivative of this side. And we're going to take the derivative with respect to x. How do you know? Because the denominator is x. Yes, it's squared. We'll get there in a minute. Get there. That southern accent just came through really thick, didn't it? So d over dx, d over dx. We're taking the derivative, 0 over here. Derivative of x squared is 2x. The derivative of 4y squared is 8y dy over dx. Okay. Let's solve for dy dx. We're finding the derivative. We need that to go where we're going. I hesitated because I was like, yeah, we're finding the derivative, but we're going further. So negative 2x, 8y there. So dy over dx equals negative 2x over 8y. We'll reduce it and make it negative x over 4y. The negative can go in the front or the denominator or the numerator, any of those. Okay, so here's the deal. We actually need to find the derivative of the derivative. So we're finding the second derivative. It's the rate of change of the rate of change. Is your rate of change increasing? Is your rate of change decreasing? It's that sort of thing. And this one's going to turn out to be kind of neat. You're going to like the way it turns out. I hope so anyway. So this is our derivative. There it is. And we are going to take the derivative again. Well, how do you know? Well, based on the fact that they use d squared y and dx squared. And the obvious question is, why is it not dy squared over dx squared? It's not, and here's why. So let's take the derivative of both sides with respect to x. So d over dx, d over dx. And when I do that, if you look at the way it's written on the left side of the equation, we have d, I don't want to say times, we're doing an operation, but we're taking the derivative of dy. And if you're just going to simply look at letters, this is probably not the best way to think about it, but looking at letters is, well, I took the derivative of y twice. So basically I have two d's in this case. But the denominator I have a dx. And you can square it. You don't have to put parentheses around it, so I'm going to leave the parentheses off. So again, here's the deal. I just took the derivative of y twice, and it was with respect to x twice. And that's why that shows up the way that it does. Now we're going to take the derivative of the derivative, which means we are going to have to use the quotient rule. We have a numerator and denominator. I'm going to let the numerator carry the negative, and the denominator will be 4y. So the derivative of negative x, I'm doing f prime g minus f g prime, all divided by g squared. Hit my watch on the board. Oops. So f prime g minus f g prime. Okay, the derivative of 4y is 4 dy over dx, all divided by g squared. I gently tapped it that time. There we go. Okay, so we could say we're done, be like, oh yeah, I'm finished, that's great. No, let's clean this up. That's just gross. Nobody wants to look at that. We'll bring my work up here. So here we go. Get this little desk out of the way that you can't see. We're going to have, bring it up here, negative 4, well, let's bring it all the way up here. There we go. Negative 4y plus x times 4 dy dx. So plus 4 x dy over dx, all divided by, and I'm going to go ahead and call it 16y squared. I think that's fair and pretty easy to do. Looking through my work, making sure I didn't make any mistakes. F prime g minus f g prime, all divided by g squared. Got it. We're good. Okay. If you want to stop there, sure, fine, whatever, but don't stop there. Just don't. Okay, I notice that everything is divisible by 4, so I'm going to divide by 4. I'm also going to do something else at the same time, and it's going to look like this. So first of all, negative y plus x times dy dx. And I'd love to put dy dx, but instead, let's actually put what dy over dx is, and it's this. Negative x over 4y. So negative x over 4y goes there. Ah, things are going to get clearer. Also in this step, I'm dividing everything by 4 because all the terms are divisible by 4. So we'll have 4y squared. Okay, so we have this situation with a fraction that has a fraction in it. It's called a complex fraction, and you may have seen this before, but in my opinion, that I learned from a coworker many years ago, the best way to get rid of a complex fraction is to multiply by the least common denominator of everything. So the least common denominator of all these three fractions, this denominator is 1, this denominator is 1, this denominator is 4y. It's to multiply by the least common denominator, which in this case is 4y. So I'm going to multiply everything by 4y, and it's going to wipe out those. Those cancel. And so the next line is going to look like this. Let's see. Negative 4y squared, and then negative, because positive times negative, so negative x squared, all divided by 16. That 16 pop back up, and then y to the third. Okay, so we probably would say, oh, we're done, and we're done, but we're not done, because there's something really cool that's about to happen that's not obvious. There is a negative in the numerator that I'm going to factor out, and then when I factor it out, it'll become slightly more obvious, and then we'll do it, and you'll say, ooh, that was cool. It's cool the way that worked out. So negative 1, and then 4y squared plus x squared, all over 16y cubed. Okay, there it is. And we are going to stare at that for a second, exactly 1 second, starting now. And then we say, oh, that numerator looks very familiar to me. Just drop the lid to my marker. Oh well. That numerator looks very familiar. Parentheses. 4y squared plus x squared. 4y squared plus x squared is equal to 4. So what I really have is negative 4, negative 4. All this is 4. In the wrong order, but you know, it's okay. Addition is commutative. Over 16y cubed. 16y cubed. And we're almost done. We can reduce it. Negative 1 over 4y cubed is the second derivative.